Okay, which of the equations below represents y as a function of x? Okay, so this is gonna test us out a little bit. Again, when you're looking at an equation, one thing you might want to do is isolate the y. So for this one, to isolate the y, I could subtract x from both sides. Maybe I'll type these out. And I get y is equal to 8 minus x. Now remember before, when we had that square root, we had plus or minus. When you have just a regular equation, y equals 8 plus something minus something x, you're good to go. Okay, this one is a function. There's no way we could put in x and get anything, again, get more than one answer for y. Let's try this next one. Well, to isolate y, we would have to divide by negative 2x and take the fifth root. Now, with square roots and fourth roots, you have to put plus or minus in front. But with odd numbered roots, you don't have to do that because odd numbers keep their sign. Negative 1 to the fifth power is still negative 1. Okay, it doesn't change the negative to a positive. Hopefully this is making a little bit of sense. This one is also a function because when I put a number in for x, I only get one possibility for y. Let's look at this one, this next one. So again, if we tried to isolate the y, we would have to subtract the x squared from both sides. And then we would have to take the square root to get rid of the squares. And what do we have to do when we take a square root? We have to put plus or minus in front. And we get y is plus or minus 6 minus x squared, which means every time I put a number in for x, I'm going to get two answers, the positive answer and the negative answer. And that is not what we want. So this is a no. Okay, here is another one, yx to the fifth equals 7. Okay, this one, again, odd powers make us okay. So this is going to go ahead and this will be a function. Y equals absolute value of x plus 4. Now, when we're solving absolute value equations, we do get two answers. But notice those two answers would be for the x. So we get two different x values for one y. The y is not going to be have two answers. Let's try out a number. Let's say my x was 1. 1 plus 4 is 5, and the absolute value of 5 is 5. And there was only one possibility for that. We can try another one. Let x equal 0. Well, 0 plus 4 is 4, and the absolute value of 4 is always 4, not two possibilities. Okay, so this absolute values, yes, this is a function as long as it's the absolute value of x and not the absolute value of y. What about x equals 5? What did we say? We talked about this in our lesson a couple of lessons ago. I think it was assignment 2. What does the line x equals 5 look like? Now remember on the graph, are we going to have x repeated? Yeah, over and over again, because x is always 5 no matter what y is. Can we repeat x's and still have the function? Absolutely not. So this is not going to be a function. Recall its graph would be a vertical line where x is 5. And notice I'm touching all kinds of points if I draw a vertical line there. This one is a no. Anytime you have x equals a number, it's not a function. Okay? Y equals a number is okay. X equals a number not okay because you're repeating the same x over and over again for different y's. And here's our last guy. Is this a function, yes or no? Now, you might, from our examples up above, see the square root and say, Mrs. Nebaker said that when I have square roots, I have two possibilities. But I want you to notice this is the function we started with. We haven't done any manipulating to it. This is what they gave us, and the original function they gave us did not have a plus or minus in front of it. The only reason our examples up above had plus or minus is because we isolated the, is because we isolated the y and had to take the square root to get rid of that squared. Okay? This one originally had a square root in it. It's absolutely okay. If they put plus or minus there, then it would not be a function. But the original function was the square root of x minus 8. No plus or minus in front. So this is, yes, it is a function. And I just noticed as I was going through that I skipped this problem up here. So let's do this one right here because I put that one up there on purpose. It's pretty important. Is this one, this no right here goes with that friend up above. Okay, so let's do this problem here. Y equals x squared plus y plus x squared equals 14. Well, to isolate the y, all we would do is subtract an x squared from both sides, and we would have y equals negative x squared plus 14. Okay, no matter what x I put in here, I'm only going to get one answer. Okay, it's okay to have a squared on the x. It's when we have a squared on the y that we usually come out with a problem. So this one is yes. Okay, sorry about kind of overlapping here. This no goes up here with this example. It was a y squared, almost always a problem and makes it not a function. X squared is okay. Okay, so to recap, I'm going to go ahead and erase. This was a yes. This was a yes. This one was a no because of the y squared. This one was a yes. This one was a yes. A yes. Uh-oh, this next one was a no because it was a vertical line. I had x repeated as 5 the entire equation. And our last one was a yes.